cost depreciation, the value of an item decreases how often that item has been used, how many times it has been used. So let's have a look at an example on unit cost depreciation. So now we have, these are the formulas we need to be familiar with. And also, well, this is the initial cost. This is number of times it has been used. And this is how much it's depreciating. It could be how many kilometers a car covers, how much it's depreciating. And this one is the number of kilometers covered. So the number of times it has been used. And the future value is the cost price minus the total depreciation. And also, you are expected all your answers to be in nearest cent unless stated otherwise. And nearest cent means rounding your final answer to 2 decimal places. So that's what the VCEE expects you to know. All right, let's have a look at an example based on this concept. The unit cost. This is an examination question. A coffee machine purchased for 12,000 is depreciated in value using the unit cost depreciation. The rate of depreciation is 5 cents per cup of coffee made. So every cup the coffee machine makes, it loses value of 5 cents. So the question is asking us to calculate the number of cups of coffee that the machine produces per year. So we know that it's always a good idea to write it down, the variables given. So this is how much it depreciated the whole year. And every time the machine makes a cup of coffee, it depreciates by 5 cents. So we need to work it out what A should be. So now this is going to be the D value, which is 1,440 divided by how much it's depreciating by making 1 cup. So that's going to be 28,800 cups. That's what the machine produces in 1 year. The recurrence relation above, which is this one here, could also represent the value of the coffee machine depreciating a flat rate. So they are asking us the annual flat rate. So now to find the annual flat rate, so D equals to R over 100, V naught. So we know enough information to work it out what R should be. So we know what V naught is, which is 12,000. We know what the D value is. The D value is 1,040. So we can use the solve menu 31 on your calculator using the TI. And that's how you do it. So let's do let's use the calculator. So press menu number 3 1, and I'm just gonna write 1440 equals to control the division sign, put R there, over 100 times 12,000 comma R. So that gives us 12%. So it's reduced, the flat rate is 12% per annum. So complete the rule below that gives the value of the coffee machine in dollars and cups. So that's going to be 12 here, 12,000, that is there. And the machine is losing every time it makes a cup of coffee, it's losing that much. So that's going to be 0.0. So rather than plus, we're just going to make it minus. All right, and we have this one here. The initial cost of a vehicle was 28,850, and its scrap value means effective lifetime. And it's always a good idea to write it down all the given variables. So now we know. So this is the formula for unit cost depreciation. Always write it down, the formula, but all the given variables. So now we know the value of the scrap value, which is the VN, and 5,050. And the initial value was 28,850, and the number of kilometers the car covered was 80,000. So want to find out what D is, then we can actually use the solve, which is basically this one here. Similar as what I did before, just going to use the solve. So the car is actually depreciating every time by 28.5 cents per kilometer. So that's going to be dollars every kilometer. So now the next part of the question is asking us calculate the amount of the depreciation in a year when 16,497 kilometers were traveled. So all we have to do is we're just going to multiply these two. So let's do that. 16,000, what was that? 16,497. So that gives us 4,000. And the question was asking us nearest cent, so that's going to be 65. So we need to make it 2 decimal places. All your answers has to be in 2 decimal places, nearest cent. All right, and let's have a look at the next one. So I've done B. Set up an equation to determine the value of the vehicle after traveling n kilometers. So we know that it's losing a value of that much for every kilometer it covers. So we just need to use this formula. So C is going to be, so if we write it down the formula itself, and we're just going to substitute everything we know. So this time we're just going to keep n as it is. So our value will be 27,850 minus 0.285 n, because that's how much it's depreciating every kilometer it covers. All right, and the next part of the question, so we have done A, we have done B, we have done C. So the next part of the question is asking us and the future value after it has covered 60,000 kilometers. So what will be the future value of the car after it has covered that much? So all we have to do is just substitute that back in here. So that's going to be 28,850 minus so the car will be worth 10,750. All right, that's the next one. Then set up a depreciation schedule table that lists the future value for every 20,000. All right, for every 20,000. So the best way of doing this one is by using the by using the spreadsheet control doc list and spreadsheet for every 20,000. So now remember you started with 0, so we're going to be every 20,000. So it's going to be 20 here, 20,000, and you have got. I'm just going to keep this one as to be a decimal. It's going to be 40,000. Yep, for every 20,000. So that's going to be, so let's actually get this one here. I'm just going to call this one as to be a distance. And I'm going to future value, I'm going to call future value. Present, it's 27,850. And now every time it's actually losing a value. So we need to put the formula, which was, the formula was, and this cell, we're just going to put that cell. So put the equal sign there and click that cell, minus, that was the initial V naught, 0.285 times D so D1 times D2 let's do it again. No, A2, sorry, not D, A2. A2. That's better. A2 should be A2. All right, now we can just put the cursor there and press menu 3 and drop the menu down. That actually gives you the value of the car after a certain period of time. So it's changing. Now this one has to remain. So this one has to remain. I want to put the dollar sign because you don't want that initial cost to change. So we're going to put the dollar sign in order to keep the initial cost. By including the dollar sign, it actually keeps the initial cost. So this is how you do it. So you put the dollar sign before the B1 and in between the 1, and that keeps the initial cost. And as you can see now, so now if I drop that, that's how it's going to be. Yep, the initial cost. The only thing that's changing is actually the kilometer the car is covered. All right, and let's go back to. All right, now our last example. This is also another exam question, so let's do this one here. All right, Phil is a builder who has purchased a large set of tools, and he used recursion to show that. So always show that question, they want you to show the working out. It's a recursive calculation is required, so you need to use, you can't just use your calculator in order to find the answer what it is. You have to use the previous value in order to get the next value. So what is that supposed to mean? Well, it means V1, so in this case here, V naught is given, so you need to use the V naught, which in this case is this one here. And you need to do your calculation based on that. Then you need to use the V1 value in order to obtain V2. So you need to do 0.9 times 54,000. So they are expecting you to show the working out as required of you. So that is recursive calculation is required. Remember that. Show that question. All right. What is the annual percentage rate? So now here you could use the solve if you want, because you know the other multiply, because this is a reducing balance. It's they've already told you, and that's going to be 1 minus R over 100. And the other multiplier is 0.9, so you could use your solve key for that. Solve equals to 1 minus R over 100, comma R. So that gives you the R value as to be 10%. All right, let's do the last bit of the question 4. No, B, C. All right, now Phil plans to replace these tools when the value first falls below 20,000. And now we need to find out how long will it take that to fall 20,000. And that's basically asking us the n value. So we could use the solve key again in order to work it out what the n value should be. So that's actually a straightforward one. So let's do that and see what we get. All right, now so that's going to be menu. So menu 3.1, put the value as to be and below 20,000, so you want it to be below 20,000, and we know that that's going to be 0.9 to the power of n, and times the initial cost was 60,000, comma n. And that takes about 11 years. It's over 10 years, so it must be 11 years. So that's 11 years. It takes 11 years for the value to fall below 20,000. So 11 years. All right, now this one here, we're going to do the same thing again. So with the flat rate, if you're using a flat rate, the value of the tools, flat rate. So now here, the initial cost is 60,000. That doesn't change. If we use flat rate, so that's going to be, and the VN, how much it's actually depreciating each year. And we need to work it out what the D value should be. And without. So this is flat rate, so we only need to work it out what D is. So we're going to use R over 100 times the V naught, which in this case is going to be, our R value is 8%, times the V naught, which is 60,000. So 4,800. So now here this bit will be 4, and Vn will be whatever the initial cost was, or you can just do this because that's what they want us to do, minus 4,800, and that's what it was. All right, that's the end for unit cost depreciation.